In these notes, we're going to review how to graph sine and cosine or sinusoids with different periods. So what's different in these equations is now we're going to have a sine bx or something like a cosine bx, whereas in the past we just had x. So we're going to have a coefficient in front of the x or the angle. So how are we going to do that? Looking at the equation, we can determine key features that's going to allow us to set up our graph in a way that'll make it easy to graph these functions. First thing you want to figure out is what's the midline. Okay, the midline is going to be y equals something. In this case, we don't have a vertical shift, so this d value is 0 for our particular graph. We're going to be graphing y equals negative sine 2x here. So d is 0, which means our midline is at y equals 0. The amplitude comes from the absolute value of a. So that's going to be our amplitude. So the absolute value of a in this function. Here a is negative 1, so the absolute value of negative 1 is 1. And the period, what we need to remember is the period for the parent. So period for y equals sine x and y equals cosine x is 2 pi. That makes sense, right? If we have a unit circle, it takes us 2 pi radians to go around the unit circle and complete one cycle, which means for our parent functions, sine x and cosine x, the period's 2 pi. So what happens when we have a horizontal stretch or shrink? That's what this b value does. It's going to give us a horizontal dilation. We can find the new period by taking the period in the parent function 2 pi and dividing it by b. So in this particular function, b, I usually use lowercase b. These notes use uppercase b. B is equal to 2. So our period is going to be 2 pi over 2. And then always simplify. This will be pi. So we have a period of pi. Next, we want to figure out where the maxima values are going to occur. Those maxima values will occur taking the midline plus the amplitude. So in this case, the midline is at 0, the amplitude is at 1 or is 1. So we're going to have maximum values at y equals 1. Minimum values, we're going to take the midline and subtract the amplitude. So 0 minus 1 is going to be negative 1. That's where our minimum values are. The next thing we want to do is figure out what the increment size is, or sometimes I'll refer this as key points, the interval for key points. How often they occur? They always occur at 1/4 times the period, or you can think of it as the period divided by 4. So for this particular graph, we found that the period is pi. So we're going to have key points every pi over 4. And this is going to be important when we set the scale on the x-axis. If we use this increment for our scale, it's going to be really easy to graph sine and cosine functions that have horizontal dilations. Step 3 is to label your axes. Step 4 to determine the pattern. That means the key points are going to occur at the maximum, the midline, and the minimum. And then we're going to go ahead and plot our points. So let's go ahead and sketch this graph like we did on previous graphs. So first I'm going to sketch in the midline. I'm going to put a scale on the vertical axis. So I'll say one large line is 1 unit. I'm going to sketch in my midline. And that we found was at y equals 0. The amplitude is 1, which means we go up 1 unit. So I'm going to sketch in a line for the amplitude to get the maximum, y equals 1. And then I'm going to move down the amount of the amplitude from the midline, and I'm going to sketch in y equals negative 1. This makes a nice skeleton for our points for our graph. And now what's new here is in the previous graphs, the period was always 2 pi, so we always set our scale to be 2 pi over 4, which is pi over 2. So we set the x-axis always to be in increments of pi over 2. For this particular graph, we want increments of pi over 4. So that's how I'm going to mark off my x-axis. So I'm going to make each one of these large increments be pi over 4. So I've written pi over 4. The next one is 2 pi over 4. So I'm going to write that off on the side, but then I need to simplify that, which is going to become pi over 2. So I was at 2 pi over 4. I add one more pi over 4. That will put me at 3 pi over 4. The next one, if I add another pi over 4, that would be 4 pi over 4. But 4 pi over 4 simplifies to pi. The next one, I add another pi over 4. I was at 4 pi over 4 plus 1 pi over 4 is 5 pi over 4. The next one, 5 pi over 4 plus 1 pi over 4 is 6 pi over 4. And then we need to simplify that. So that's going to become 3 pi over 2. Remember, we were at 6 pi over 4. We add another pi over 4. That's going to become 7 pi over 4. And then 8 pi over 4 is 2 pi. So now we have set the x-axis to correspond with where we have our key points. And now we have to think about where we're going to start. I'm going to write this up by step 4. So this is a sine graph. Okay, so sine starts at the midline. So that means on the y-axis. And then we have to determine, is this going to go up or down from the midline? So since we have a negative in front, so it's a negative sign, that means this graph is going to be a reflected. So I'm going to write that down. This is a reflected sine graph, reflected in x-axis. So that means it's going to start at the midline and go down as we go from left to right. And that's going to tell us how to plot our points. So the first point that I'm going to graph is at the midline. So I'm going to put a point at 0, 0. My next key point is going to be pi over 4 over. That's a quarter period. And this graph is going to be going down as I go from left to right. And it's going to go from the midline to a minimum. So I'm going to plot pi over 4, negative 1. Then I'm going to go over another pi over 4, which will put me at pi over 2, in which case I'll be back at the midline. Then I'll be at 3 pi over 4 up to a maximum, which is 1. Then I'm going to be back at the midline for my next point, which is pi over 4 away, which is going to be at pi 0. And then we can continue the pattern. So 5 pi over 4, negative 1, 3 pi over 2, 0, 7 pi over 4, 1, and 2 pi, 0. And now I'm going to sketch the graph. When I do that, I'm going to make nice kind of U-shaped curve. So this is what's called concave up. It kind of looks like a little cup. And then I'm going to sketch the top part or the stuff over the midline, making those concave down. Then I'm going to sketch a nice sine graph. I'm going to put arrows on the ends because this graph continues forever. And now we've done it. We've graphed y equals negative sine 2x. On the back side, we're going to graph two other functions, and I'm going to walk you through how to do it. I encourage you, if you'd like, to try to sketch these on your own and then watch the video to practice or to check your work. Okay, so let's begin. The first thing we want to find out is the amplitude. The amplitude is the absolute value of A, which is going to be 3. And then the midline is determined by D. D here is 0, so that's going to be y equals 0. We want to know the period. So the period is always 2 pi over b. B is the coefficient of x. So b is 4. So our period, if we simplify this, is going to be pi over 2. And what we really want to know is how often the key points are. So key points occur every 1/4 period. So these key points are going to be 1/4 times pi over 2. Multiplying the numerators, we get pi times 1, which is pi. Multiplying the denominators, we get 4 times 2, which is 8. So this is going to be used to set the scale on the x-axis. Okay, and then let's figure out where we start for this. So that's the next thing I find is the starting point. On the front side, I think it says the pattern. I like to refer to it as the starting point. So where does this graph start? It's a cosine. So cosine normally starts at a maximum or minimum. It has a negative leading coefficient here. So this is reflected in the x-axis. So this is going to start at a minimum value. And now we're ready to graph this function. So I'm going to put scales on both the x and y axes. So for the y-axis, I'll do 1 square, or it's 5 little squares, or 1 large square being 1 unit. So I'm labeling that now. On the x-axis, you want to use the interval that we found, which was pi over 8, right? So we want to set our scale on the x-axis to be the frequency of our key points. So we're going to say this first increment is pi over 8. The next one is 2 pi over 8. So 2 pi over 8 simplifies to pi over 4. Remember, we were at 2 pi over 8. We're going to go 1 more pi over 8. So 2 pi over 8 plus pi over 8 is 3 pi over 8. Now we're at 3 pi over 8. We had another pi over 8. That's going to be 4 pi over 8. Simplifying this becomes, we get pi over 2. Now we're at 4 pi over 8. We add 1 more pi over 8. That's going to become 5 pi over 8. Then 5 pi over 8 plus 1 pi over 8 is 6 pi over 8. And we're going to simplify that, dividing 2 out. So we're going to get 3 pi over 4. So remember, we were at 6 pi over 8. Add 1 more pi over 8. That's going to be 7 pi over 8. And then 8 pi over 8, which simplifies to pi. So now we have the scale on the x-axis. The starting point we determined was a minimum. So that means at the y-axis, this is going to start at 0, negative 3. So let's go ahead and plot that, 0, negative 3. And now every pi over 8 units on the x-axis will get a new key point, and we're going to follow the pattern. So if we were at a minimum, oh, you know what I didn't do on these? I forgot here. I'm going to go ahead and sketch in the skeleton for the maximum value, y equals 3, the minimum value, y equals negative 3, and the midline, because that is where we're going to plot all of our key points. So we started at a minimum. We go over 1 more increment, or 1 more quarter period, and we'll be at the midline. So pi over 8, 0. Go 1 more quarter period, we'll be at pi over 4, 3. 1 more quarter period, back to the midline, 3 pi over 8, 0. 1 more quarter period, pi over 2, negative 3. 1 more quarter period, 5 pi over 8, 0 at the midline. The next one will be at a maximum at 3 pi over 4, 3. Then 7 pi over 8, 0, back at the midline. And finally, pi, negative 3. And now I'm going to sketch these, making nice smooth curves with the proper concavity. And I'm going to put arrows at the ends to show that this graph does indeed continue on forever. And that's a graph of y equals negative 3 cosine 4x. Now we're going to do 1 more graph. So you can follow along with me or try it on your own and then check your work afterwards. Okay, so looking at this equation, the amplitude is 2. That comes from this a value. The period is always 2 pi over b. The b value here is 1/2, so this is going to be 2 pi over 1/2. Dividing fractions, easy as pi. Flip the second and multiply. So this is 2 pi over 1 times 2 over 1, which is 4 pi. And then the increment for key points on the x-axis is always 1/4 times the period. So here we have 1/4 times 4 pi, which is pi. So that's going to be how we're going to set our scale. And the next thing we want to know is the starting point. So the starting point, this is a sine, and it's not reflected in the x-axis because a is positive, right? It's not a negative value. So this means it's going to start at the midline and go up from left to right as we pass through that point. Okay, so this graph is going to start at x is 0, and the midline is going to also be, oh, I forgot to write that down. The midline, let me write that down. I skipped that, so let's write it here. The midline, here d is 0, so it's going to be at y equals 0. Did I skip that in my analysis above? No, I have it in the one up above. Okay, so the midline's at y equals 0, so the starting point is going to be at 0, 0. Okay, so let's go ahead and sketch this graph. I'm going to put a scale on my axis, so I'm going to put one of these large units is 1 unit on the y-axis, and on the x-axis I want to count by 1/4 period, which is pi. So this will be pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, 7 pi, 8 pi. And now I'm going to sketch in the skeleton. So I'm going to sketch in the midline. That was at y equals 0. The maximum will occur going up to, using the amplitude, I'm going to go up to and down to. That'll give us our maximum and minimum values. So these are our max, y equals -2 is the minimum. And we said, since this is a sine graph, it's going to start at the midline. And since it's not reflected, it's going to go up as we go from left to right. So we're starting at 0, 0. When we go 1/4 period, we'll be at pi at a maximum, so pi 2. Then we'll go down to 2 pi back at the midline, 0. Another a quarter period will put us at 3 pi -2 at the minimum. Another quarter period will be 4 pi 0. And then I'm going to continue on with this pattern. And then I'm going to connect these. So I'm going to draw the part above the midline, make a nice curve and beneath it, and continue on above it and beneath it. And I'm going to put arrows at the end because this graph continues on forever.